All right, let's continue along here in our quest for graphing greatness. Okay, x equals, let's look at number 18. X equals 8. Okay, well that's a little trickier than what we're used to, which is y equals 8. A line where y equals 8, we would simply count 1, 2, 3, 4, 5, 6, 7, 8. We'd plot our point, and we would draw that straight line at y equals 8. No matter what x I choose, y always equals 8. But what is different about this equation? I see that x equals 8. So no matter what y we look at, 1, 2, 3, 4, 5, oh, I can just go 9, that x equals 8. This is kind of one of those special cases where, I mean, this is not a function. This relationship really has no real good practical application, but nonetheless, it tells us an important piece of information that no matter what y we look at, y equals 1, y equals 2, y equals 3, y equals 4, that x always equals 8. Let's look at 19. Oh, look, what do you see here? We are not in our standard y equals mx plus b form. That's trouble. So what we will do is we will simply employ our two-step process here. I'll rewrite our problem. 6x minus 2y equals 14. And so what is that two-step process? Step 1. Step 1 is to take the x term, there's our x term, move it to the other side and change the sign on it. Notice that that x term is positive. So we will rewrite our problem, negative 2y equals 14 minus 6y. Well, we're almost done. Our second step is to strip off this negative 2 from this y to get it into our normal slope-intercept form. We divide each term by the number in front of y. That's our second step. So I divide that by negative 2. Those cancel. But I have to divide every single term by negative 2. So that leaves with y equals negative 7 plus 3y. And I get that positive 3 because a negative 6 divided by a negative 2 is a positive 3. So we're not quite done yet. We're not in, whoa, I just wrote, hold on. I am really sorry for this confusion. This should be an x. 6x, because we moved a 6x over here. So that is a negative 3x. So y equals negative 7 plus 3x. Don't you just wish you could take some things you said back? I sure do. Y equals 3x, my apologies, minus 7, and that is our y equals mx plus b form. So now that we went through all that work to get our equation back into slope-intercept form, it would be foolish to not then put it on the graph to show the results, the fruit of all that labor. So let's go down. Our slope is 3 and our y-intercept is negative 7, so we go down 9, 8, 7. And our slope is 3, which we can think of as like a 3 over 1. So our rise is 1, 2, 3, and our run is 1. And we can just plot that all the way up like that. And there's our line. All right, open up your ears. Number 20. Critical piece of information here. Graph the linear parent function. The linear parent function is, holy moly. Are you seeing that? The linear parent function is y equals x. That is the linear parent function. And what does y equals x look like? It looks like this. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. In other words, y equals x. This is the linear parent function. So if we shift it, if we translate it down 4 units, we just take that b-intercept, that y-intercept, we go down 1, 2, 3, 4, and we redraw the line. Tell me about the slopes of these lines. If you said the slopes are the same, move to the front of the class. They are the same. The slopes are the same, therefore the lines are parallel. And so the new equation, since we just translated it down 4, and remember, down is a negative direction, our new equation is y equals x, translated down 4 units, is then minus 4. Describe what happens when y equals 2x minus 3 is translated 5 units up. Well, if we can describe it in an equation. If we're translating it 5 units up, then our equation becomes y equals 2x plus 2. Because we had an equation that was sitting down here, 2x minus 3. And if we translate it up 1, 2, 3, 4, 5, it moves all the way up here. So our translated function remained parallel to the original function, but it got shifted up 5 units. That would be a good description. Change 7x minus 3y equals 21 into slope intercept form. Show your work. Okay. 7x minus 3y equals 21. Step 1, take that x term, move it over here, change the sign. We're left with negative 3y equals 21 minus 7x. Divide every term by the number that's in front of y in order to isolate y. We're left with y equals negative 7 plus 7/3 x. And I'm going to go ahead and just rewrite it. Y equals 7/3 x minus 7. Okay? The x-intercept, remember, we can always find the x-intercept by setting y equal to 0. So when y equals 0, let's see what x equals. So 7x minus 3 times 0 equals 21. So 7x equals 21, x equals 3. So when y equals 0, x equals 3.